in a previous video I talked about the halogens, right? So in this video I'm talking about the compounds of halogens. Now there are different compounds of halogens, and today in this video we're talking specifically about the hydrides, and I'll be talking about the laboratory preparations of different types of hydrides. Three major types of hydrides, which are the hydrides of chlorine, the hydrides of bromine, and the hydrides of iodine. So I'm talking about the preparation. Now let's start from the hydrides of chlorine. Now, in order to prepare an anhydride of chlorine, you combine sodium chloride with tetroxide 6 acid to produce sodium hydrogen tetroxide 6 and HCl. So the equation of the reaction is NaCl plus H2SO4 will give you NaHSO4. That is sodium hydrogen tetroxide 6 plus HCl. So this is one hydride of the halogens, and this is specifically known as hydrogen chloride. Now this hydride, which is a combination of hydrogen and chlorine, is a very popular acid and it dissolves a lot. It's very soluble in water. It dissolves, and even when you are preparing it, there's a process known as sucking back, where because of the extreme solubility of the gas in water, it becomes sucked back. So when the rate at which the gas is being dissolved is faster than the rate at which the gas is being produced, then the reactant in the beakers will begin to be sucked into the funnel, which stops the reaction. Now that's what's known as sucking back, just in case you encounter it in your examinations. Now let me draw the apparatus for this reaction. Basically what this entails is you have a beaker, and in this beaker you pass some amount of tetroxide 6 acid. Then you pass it inside a sodium chloride, which is ordinary salt. Then this salt you now pass it through a beaker, a sealed beaker containing hydrochloric acid. Sorry, you pass it through a sealed beaker containing tetroxide 6 acid. And this concentrated tetroxide 6 acid is also used to dry the gas formed. So this H2SO4 that is formed here, when you pass it through it dries the gas, and when you pass it out, you can see that the gas will be formed in an open jar. So the gas will be formed in an open jar. So basically, you combine sodium chloride and concentrated tetroxide 6 acid, and then you pass it through another concentrated tetroxide 6 acid to dry the gas. Then you pass into an open jar containing nothing. So the gas will stay there because it is denser than air. That is the preparation of hydrogen chloride. Now let's go on to the second element we'll be talking about today, which is bromine. Now the preparation of hydrogen bromide, and this is the laboratory preparation of hydrogen bromide, is also similar to the preparation of hydrogen chloride. So it is formed whenever you combine a stiff paste, that is a paste of phosphorus in water. When you combine phosphorus, water, and sand, and the reason why you put sand is so that you can reduce the effect of the reactions on the glass. So you make use of sand. So and that makes it uniform and reduces the effect of whenever it involves the heating of the gas of the glass, so that your glass will not be damaged. So when you mix that phosphorus and sand and then water, and you run bromine through a dropping funnel, and then when the reaction occurs, you pass the gas through to another U-tube, and that U-tube will consist of it will be packed with red phosphorus. So when you pass it through, basically you are trying to absorb the bromine. So when bromine is absorbed, you pass it through to an empty jar. So then when you pass it to an empty jar, your hydrogen bromide is formed. So basically it's also involved a jar like this. So in this jar we have this, and then we have our dropping funnel, and this dropping funnel consists of bromine. Then we pass another jar through to a U-tube, and this U-tube here, in this U-tube is packed with what's it called? It's packed with red phosphorus. Yes, red phosphorus. And red phosphorus is actually non-poisonous, while white phosphorus is actually very poisonous. So just in case it comes out in your examination, and when it passes through it, you now pass it into a jar, an open jar, and this open jar you get hydrogen bromide, or hydrobromic, rather let's just call it hydrogen bromide gas. So basically what this entails is that you have a mixture of red phosphorus, water, and sand here, and then you pass bromine through a dropping funnel into it, and then they react together it often occurs at high temperature because most reactions involving phosphorus involve high temperature, because phosphorus is used in making your matches. So, and then when you know that matches produce a lot of heat, so phosphorus automatically produces a lot of heat. So now, then you pass it through this YouTube. This YouTube is packed with red phosphorus, and the reason for passing it through this YouTube is that when you pass the gas produced, the mixture of gases produced, it will be able to remove any impurity of bromine. So, and then it is basically a secondary reaction chamber, because the bromine is also able to react with the phosphorus again the second time, and then you are going to produce more hydrogen bromide. So, but basically, this hydrogen bromide that is formed, it is also very soluble in water, and you can also collect it over water. That's another example. Next, let's talk about the last one for this video, which we're talking about is hydrogen iodide. So we've talked about hydrogen chloride, we've talked about hydrogen bromide. Let's talk about hydrogen iodide. So hydrogen iodide is basically formed when you react iodine and red phosphorus and water, just like this, but then you make use of a test tube, because iodine is rather an element that kind of sublimates. So when it sublimates, forms directly from a solid to a gas. So then when you have that iodine in a test tube and it's heated at a slanting, when you slant the test tube, so you slant the test tube in this manner, then when it is heated, so and then you pass the gas produced through to a jar, and then you have your elements produced. Basically, you support the jar in this way, and you pass your gas through. So a mixture of iodine and phosphorus. So if you pass it through a solution of silver trioxonitrate, it will give you a yellow precipitate. So that is one of the tests using your practical chemistry to test for iodine containing compounds. Then when you pass it through ammonia, it will form white fumes of ammonium iodide. So then when you pass this gas, this is actually phosphorus triiodide. When you pass it through water, it forms your trioxophosphate acid. So that is one example of how you can form trioxophosphate acid. Thank you for watching.